All right, today we're diving into one of the coolest, most elegant solutions in all of crypto, Kaspa's sync selection. It's the secret sauce that lets a really radical network structure, the block DAG, achieve something that should be impossible: perfect consensus. So let's break down how it all works.
Now, to really get why this is so important, we have to start with a bit of a mind-bending question. What if there was more than one present? In our world, time moves in a straight line, right? But on the Kaspa network, whoa, it's a completely different story.
See, with a normal blockchain, you get this single, straight line of blocks. But Kaspa's block DAG, it's building blocks in parallel. So you can imagine several miners finding a new block at the exact same moment. They're all valid, they're all legitimate, so which one is the real tip of the chain? Which one represents the actual present state of the network?
And look, this isn't just some deep philosophical question. If you don't solve this, this ambiguity would cause absolute total chaos. Without one single source of truth, the network would just stop working.
Think about it. If different computers on the network, the nodes, all choose different blocks as the present, they end up with completely different versions of history. I mean, a transaction could be totally valid for you, but for someone else, nope, invalid. That right there is a recipe for complete and utter consensus failure. And this disagreement, it's not just one big messy problem. It actually breaks down into three specific, really critical failures that would just cripple the network. Let's dig into each one. Okay, first step, we've got chain state ambiguity. If we don't know which block is the real one, then we can't possibly know which transactions are confirmed. Your wallet balance could literally change depending on which node you happen to ask. Seriously, you never know for sure how much you have, and miners, they'd be totally lost, with no idea which transactions they could safely pop into the next block. Then there's problem number 2, mining direction uncertainty. Miners have to know which block to build on top of, right? But with all these different choices, you'd get some building on block A, others on block B. All that does is split the network's hash power, which makes the whole thing less secure and wastes a ton of energy on what ends up being a losing chain.
And this leads to the ultimate nightmare scenario: consensus instability. The network could literally split. It could fracture into pieces. You could end up with 2, maybe even more, separate Kaspas, each with its own history, its own transactions, its own reality. The entire project would just fall apart. So you can see this is a huge problem. How in the world do you solve this?
And this is where the Kaspa team came in, with this just incredibly elegant solution. They called it the sync. Think of it as the anchor in this chaotic sea of parallel blocks.
So, what is the sync? It's defined as the single, highest scoring valid block that the entire network agrees on as the present moment. It becomes the ultimate source of truth. It doesn't matter if there are 10 or 100 parallel blocks, every single node on the network looks to the exact same sync as its reference point. Period. The magic behind this is the sync selection algorithm. And the key word here, you gotta remember this, is deterministic. This isn't a vote, it's not a guess. It is a precise mathematical set of rules that basically forces every node to come to the exact same conclusion on its own. You give them the same block tag, they will always choose the exact same sync. It's bringing order from chaos, completely by design. So how does this algorithm actually work? I mean, how does it sift through all those potential candidates and pick the one true sync? Well, it follows a really clear 3-step process. Okay, so the algorithm has this 3-step checklist. First, it prioritizes blocks based on something called blue work. Just think of this as the total amount of proof of work, the computational muscle behind a block and its entire history. More work, higher score. Simple. Second, it validates all the transactions. Are there any double spends? Any funny business with the coins? If so, that block is out, disqualified. And finally, it makes sure that picking this block won't mess with the parts of the ledger that are already confirmed and settled. The block that aces all 3 checks and has the highest blue work score, that's our winner. That becomes the sync. So what happens to the other parallel blocks that didn't become the sync? Is their work just wasted? No way. Absolutely not. In a really clever move, Kaspa bundles the sync with other valid parallel blocks, and together, they act as virtual parents for the very next block. This means all that parallel work still contributes to the network security. No effort is ever wasted. Pretty cool, right? This might all sound super technical, I get it, but the implications are massive for everyone who interacts with the Kaspa network. I'm talking users, miners, developers, you name it. This isn't just some clever piece of code, it's the very foundation of a system that actually works. I mean, this system just builds a better network for everyone. For you, the user, it means your wallet balance is always reliable and accurate. No more guessing. For miners, it gives them a crystal clear target. They know exactly which block to build on, so no hashing power gets wasted on chains that go nowhere. And for developers, man, their lives get so much simpler. They can build apps by just pointing to one single authoritative state, the sync, and they don't have to worry about untangling that complex mess of a DAG. There's actually a quote from the official documentation that just hits the nail on the head. This abstraction dramatically simplifies wallet and exchange development. By creating that one simple reference point, the sync, developers are basically shielded from all the underlying complexity. It makes building something like a wallet or an exchange just as straightforward as it would be on a traditional blockchain.
All right, so let's wrap this up. Let's boil it all down to the most important points. If you only remember a few things from this explainer, make it these. Okay, so remember this. The sync is basically the king of the hill. It's the valid block with the highest score. That score is mostly driven by blue work, which is all that accumulated hashing power behind it. But hey, it's not just about power. To even be in the game, a block has to have a clean transaction history, and it has to respect the network's finality rules to keep things stable. It's this combo of rules that makes consensus and Kaspa's wild parallel world actually possible.
And that leaves us with one last thought. This whole mechanism, this entire idea, is about creating certainty out of a world of parallel possibilities. By finding a way to choose one single authoritative path forward, it unlocks the potential for incredible speed and scalability. So the real question becomes, now that this fundamental problem is solved, what can a network built on this principle truly achieve in the future?